Hi all, today we'll be discussing the LeetCode problem of the day 1461. So here you are given a binary string which consists of characters only 1 and 0, and you're also given an integer k. Suppose let's say k equal to 3. So you have to return true if every binary code of length k is a substring of s. So here we have k equal to 3. So all possible binary codes of size 3 will be, let me just write them quickly. 0, 0, 1, 1, 0, 1, 1, 0, 1, 2, 3, 4 is missing. Yeah, so these are all the binary codes of length 3. So if this substring, if this string s contains all these substrings in them, then you have to return true, otherwise return false. So let's look at an example. So this is your input string, which is 0, 0, 1, 1, 0, 1, 1, 0, and here k equal to 2. So first let's list down all the binary strings of length 2. So 0, 0, 0, 1, 1, 0, and 1, 1. So now if we check one by one, 0, 0, we have it at the starting as a substring. Next 0, 1, we have it here. Next 1, 0, we can find it here. And finally 1, 1 is also present. Since all the substrings of size 2 are present in the string, we can return true. Now coming to the second example, the string is this and k equal to 1. So for k equal to 1, only these two substrings we can form of size 1. So 0 is present, 1 is also present. So in this case, we'll return true. Finally, if we see at the third input, our string is 0, 1, 1, 0 and k equal to 2. So one of the substring is 0, 0, and this 0, 0 is not present here. Even though we have 1, 1, we have 0, 1, we have 1, 0. Since 0, 0 is not present in this as a substring, we will return false for this case. Now coming to the constraints, the string length will be up to 10 power 5, 5 into 10 power 5, and it contains either 0 or 1. And the value of k can be from 1 to 20. Now let's go over the approach. So let's say we have a string s and the value of k equal to 3. So to know how many substrings we can form of length 3, so the size is 3, and at each position you have two choices. Either you can put a 0 or you can put a 1. 0 or 1. So here you have two ways of placing it. Here you have two ways, either 0 or 1, and in this position also you can fill it with two ways. So total number of strings you can form is 2 into 2 into 2, which is 2 power 3. So for k equal to 3, total 2 power 3, which is 8 strings can be formed, and these are all the 8 strings. So to generalize it, for k, total strings are 2 power k. So let me just write it here. Our total strings will be 2 per k. And also one thing we can notice, if we note down all the binary strings, all the 8 binary strings, they are basically numbers from 1 to 8 in binary. Sorry, 0 to 8 in binary, 0 to 7 in binary. So here k equal to 3. So 2 per k will be 8. So that means if we list down all of them, you will get all the numbers from 0 to 7 in the binary form. This is 0, this is 1, 2, and so on up to 7. So let me just erase this. So one thing we are sure is the total strings that we need to check is 2 power k. And they are from the range 0 to 2 power k minus 1 in the binary numbers. So to accommodate all of this, let's see what the minimum string size should be. So let's say the string size is 3. So we have the substring of 3, and we have total eight of the substrings. So to have all of this in the string, we need the string size to be at least, let me just write it, total plus your k minus 1. And let's see how we got this. So our first string will be of size 3. So suppose this is our string of some length, and our first substring is formed here. So one thing we can see is all the substrings are unique. So no two positions will completely overlap. So let's say first substring is here. So now the second substring will be here, can be here, and let's say the third substring is here, then fourth, fifth, okay, the second, third, fourth, fifth, then you have sixth, from here seventh, and finally eighth. So for size equal to 3, so for k equal to 3, and the total you need 8 substrings. So total length of the string you need is, if you count, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is 10. So you can get the 10 by adding k plus 8 minus 1. So 3 plus 8 minus 1 will give you 10. So how we got this formula exactly is, so the first is of length 3. So that is how you got the k. So let me just write it here. And for the rest of the strings, which is of this, so for each of this string, an additional character is getting added. And total, we have total minus 1 number of additional substrings we need to add. So overall, the string size should be at least k plus total minus 1. So let's quickly note down here that the string length should be at least k plus total minus 1. And one more thing we need to notice, the total substrings is 2 power k. So once we got all of this, let's actually try to see how we can solve the problem now. So again, let me take an example. We have a long substring here, long string 1 is equal to, and let's say again k equal to 3. So for k equal to 3, we have, let me note down all the strings. 0, 1, 0, 0, 1, 1, 1, 0, and 1, 1, 1. One more is missing. 5 is missing. Yeah. So these are all the substrings that need to be present in the original string. So to check that, what we can do is we can iterate on size k window on this string and note down what all the values we found. Because like we discussed, we can see all these numbers as numbers from 0 to 7. So for that, we can maintain a hash map asset to check whether a particular number is visited or not. So let's say first we iterate on the first 3 characters of the string. So this in binary will be 5. So in my set, I will add a 5. So that means 5 is present. After that, we can proceed to the next window, and we'll check what this is in the decimal. So this is 3. So once I iterate on this window, I also found 3. Next, if I iterate on this will be 6. So 6 is found, and so on. So after iterating till the last window, we'll check in the hash set whether all the numbers from 0 to 7 are found. So even if one number is missing, then we'll directly return that will directly return false. And if all the numbers from 0 to 7 are present in the hash set, then we'll return true. So now to do this, if you want to see the complexity, the total number of windows will be around the size of the string, and each window, to check each window binary representation, it will cost order of k. So if we do this, the total complexity will be order of n into k. So n is 5 into 10 power 5 and k is 20. So overall you will get a complexity of 10 power 7. So 10 power 7 might still pass, but it is a bit slow. So we'll try to optimize it further. So to do it, let's see how we calculate for the first window. Yeah, here we have k equal to 3. So for the first window, to calculate in binary, we simply do like this. This is 2 power 0, this is 2 power 1, and this is 2 power 2. So 2 power 0 into 1, which is 1 into 1, 1. Then 2 power 1 is 2 into 0, which is 0. 2 power 2, which is 4. 4 into 1 is 4. So 4 plus 0 plus 1, which is 5. So this is how we calculate the decimal value of this binary string. So this is how we calculate the value, and the value is 5. So after we process for the first window, we'll store 5 in our hash set, and we'll try to move for the second window. So for the second window, we can see there's similarity. So this is the first window, and this is the second window. So we can see these two are common, and only this character is getting removed and the new character is getting added. So we can try to think of it as a sliding window. Instead of calculating it again, we can use the answer of the previous window to get the answer of the current window. So let's see how we can do that. So for the first window, this is how we calculate 2 power 2 into this, 2 power 1 into this, and 2 power 0 into this. Let me just write it above. Yeah. So for the second window, which is this, we'll calculate it as follows. So here we'll have 2 power 2, here we'll have 2 power 1, and here we'll have 2 power 0. So if we add it, 1 into 1 is 1, 2 into 1 is 2, 4 into 0 is 0. So total we have 3. So this substring in binary is 3. So this is the how we calculate for the second window, and this is how we calculated it for the first window. So somehow we have to convert this number into this number. So let's see. So the first thing we can do is we have to subtract this value. So from 5, you will subtract this value's contribution. So from the 5, you will subtract 4. So this is done. Now in these two characters, if you compare to your next window, here it's 2 power 1, where in the next window it is 2 power 2, and here it is 2 power 0, and in the next window is 2 power 1. So to convert this into this, you will multiply your remaining value into 2, so that this will be 2 power 2 and this will be 2 power 1. So let's multiply by 2. So when you do 5 minus 4, you'll get the value as 1. So to this 1, when you multiply by 2, you get the value as 2, and it will become something like this: 2 power 2 and 2 power 1. So now the last step you need to achieve this is to just add the additional part which is being introduced in the new window. So the additional part, you'll always add it directly because 2 power 0 is always 1. So to your value 2, you will add this value, and since this is 1, you will do 2 plus 1, and that is how you reach 3. So using the previous window value, you first subtracted the leftmost value, and then you multiplied by 2 and added the current value to form the answer for the new window. So this is how we repeat for all the windows to find the answer optimally. Now let's quickly code the approach so it will be a bit more clear. So first thing, we'll try to calculate the total number of strings. So total will be 2 power k. So we can just write 1 left shift k. So you got the total as this. So first thing you will check is whether your string is sufficient size enough to get all the characters, all the substrings. So let's say if s dot length is less than k plus total minus 1, you can directly return false because your string is not long enough to accommodate all the uh, 2 power k substrings. So once this is done, let's actually start finding the answer. So first you need to find the answer for the first window. So for that, let me take a variable number equal to 0 initially. And let me just iterate on the first window. So I equal to 0, I less than k, I plus plus. So initially, there is a multiplier and it is 2 power 2 for the first one, and next it will reduce by 2. So it is 2 power 1, and finally at the last one it is 2 power 0. So let me just iterate it in the reverse way. A minus 1, A minus minus. So directly we are starting at here. So I'll just say why we are doing it. Also, let me take a variable power, and initially it will be 1. So 1 denotes 2 power 0. So in your number, you will just add dot caret I minus 0 into power. So here 1 into 1, 1 gets added in your answer, and then your I moves to the left. So when I moves to the left, to the current character, you have to add 2 instead. So previously it was 1, now it's 2, and next it's 4. So at each iteration, you will increase power by 2. Power equal to power into 2. So first let's write the value. First number 0. So in your num, you're adding 1 into 1. So num becomes 1. And after doing it, power value was 1. Now power will become 2. Next, when you're at here, since s dot caret I minus 0 is 0, so 0 into this, you won't get anything to your answer. But again, power is getting increased, multiplied by 2. So power becomes 4. So finally, when you reach here, it is 1 into the power, which is 4. So 1 into 4, you will add it to your number. So finally, the result is 5. So the first window represents 5 in binary. So once this loop is done, you have calculated the answer for the first window. So instead of creating a set, let me just create a array, Boolean array, which will store all the values. So initially all the visited values are false. So whenever I visit a new value, so I'll say visit of num equal to true. And also I want to count how many unique values I visited. So for that purpose, I'll just maintain a counter. Or to make it more clear, we can just use a hash set. Let's say visit. So we have calculated the first number, the number of the first window. So let's add it in our hash set. So visit.add number. So once this is done, we have to move our window forward. So for that, let me take few variables. Initially, left will start from 1 and right will start from k. And also we need to store this 2 per 2 value somewhere, because at each step you will remove this value by multiplying with this 2 per 2. So let's say power equal to, so 2 power 2 is basically same as 2 power k minus 1. So in power, I'll just store this value. For 2 power k minus 1, we can just do 1 left shift k minus 1. So this is same as 2 power k minus 1. So now let's start the sliding window. So while right is less than s dot length, right plus plus, and left plus plus. So now first step is, so this is your previous window and this is your new window. The first step is to subtract this values contribution. So number minus equal to dot L minus 1 into this power. So this contribution is removed. So the now the resultant number you have to multiply by 2. So after multiplying by 2, finally you have to add the contribution of the new number which is getting introduced. So number is equal to dot add r yeah. And here also I think we need to subtract a 0 to get the integer value, because it's a character. So when we subtract it with 0, if it's a 0, then this value will be 0, and if the character is 1, then this term will be 1. Similarly, we do it for this as well. So the 3 steps are done. We first removed the previous window's character, multiplied the current window by 2, and then added the new character. So after all this is done, we'll add it in our hash set. So visitor.add number. Okay, so once the while loop is done, we have iterated on all the substrings. So now, if the hash set size will be equal to the total, that means we have found all the values. Else, we didn't find the answer. So directly we can return is dot size equal to total. So if it's equal to total, this will return to true, and if it's not equal to total, then it will return false. Let me test it now. This is total. Yeah, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So coming to the time complexity, so first we are iterating on the first key elements, and then in the while loop we are iterating on the rest of the string. So this will be roughly order of n minus k, and this will be order of k. So total n minus k plus k will be order of n. So total time complexity will be order of n. And come to the space complexity, we are creating a hash set of size total. So total is 2 power k. So space complexity will be order of 2 power k. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.